Okay, this is video number 190. It's Thursday. We're working on the Zodiac table. We're working on the Leo symbol now. Well, I just want to say that because sometimes when I don't say that at the beginning of the video, I don't get these numbers right. So, and then that kind of sucks for archiving things. Okay, so let's open up the main Zodiac table file here. And let's kind of start stubbing in some code, right? So here's this cutting sheet code for the Cancer symbol. And we are going to modify, right? We cut and pasted that so that we can modify it into the sheet for the cutting sheets for the Leo symbol code, right? So anywhere we see Cancer, we're going to replace that with Leo. And then anywhere we see this can right here, we're going to replace that with Leo, right? So, so this will be Leo 1, Leo 2, and the function we're going to do is we're going to call cut Leo with a 1 as the second parameter, and then this other function wrapper is just 2 as the thing, right? And then I think that's all the refactoring. Oh wait, one more thing. Cancer is still here, and Cancer is here. We gotta just, okay, see, no more colors. There's no more colors in here, right? So we token highlighted all this, and now it's all good. It's all refactored, cool. So this code doesn't actually exist yet, but we're consistent enough with our habits that it will soon. We'll close this, we'll close that. We'll go over here, and this is the Cancer code we wrote, right? So we're going to make another section for the Leo code now. So we're just going to say Leo code, right? We're just going to keep with that kind of consistent naming convention for now. And down here, we'll also call this Leo code. And this is going to be the last thing that I'm going to do before I just stop coding, I think, because I am really tired. Module, right? So module, ZODIAC Leo, right? SBC. And then there's some code that goes in here, right? Now, as far as testing this out to make sure that it works correctly, we're going to steal this wheel frame function here because we're making sure all these Zodiac symbols fit inside of this wheel frame. And we also want to call this as well, right? So we want to call these two things to get some feedback as we're working on this. So ZOT SBC is the SBC object for this file, and this is the generic SBC parameter. So when we're SBC is just some size constants, so that if we try to mix and match files, we have this kind of state bundle object that will make that possible. The way we did a lot of our laser cutting files, it's not possible to mix and match files without having variable name collisions and weird things happening. So we're trying to make this in a more mix-match friendly kind of way. Okay, so anyways, we got that, right? So now we're just going to hit F4 over here, and we're going to do top view with zoom extends, right? So we have just this base pattern here. And the first thing I want to do is I want to look at my reference. And I'm thinking about these two circles that are tangent to each other. I'm thinking like 60 degrees. Now, it would be cool if we could just keep things on the midline, but I don't know. Let's get the first two circles working, and then we'll work on it from there, right? So, I think we're gonna do, yeah, just two circles, right? So, of different sizes makes up the. So we'll kind of keep on this pattern of kind of naming these sections. And why am I going from bottom to top? I think I'm going from bottom to top here because I was going from bottom to top with the new code I was adding as well, so that I don't have to scroll all the way to the bottom. But it would make sense for this to be top to bottom and the other to be bottom to top, so that way it's easiest to scroll between these two sections. But whatever, let's not worry about that. So ZOT Leo and imprad big. Actually, we have a big and small rad again, right? So we could take a guess, right? We could try these already, right? We already have these. We could just throw those in there, and maybe they'll work, right? Maybe they'll be good enough, but we'll be able to modify them later. Okay. So the big radius, the small radius is the one we actually want to focus on first. And within here, we're just going to say, okay, we have a vcarve inch wheel, takes the SBC object, and then it takes the radius, and then it takes a thickness. So the thickness is the thickness of the zodiac signs, right? So the zodiac signs use this thickness to render themselves. So you want to keep with that same kind of thickness and just see what happens there. So there, we got this kind of circle here. Now, do we really want the small radius thing first? Yeah, we want to try the small first, and then we're thinking, you know, we put it over to the left, right? So but before we put it over to the left, it might be easiest to figure out the other circle first, right? So, well, actually, if we want them to tangent each other, it'd be really easy to make them tangent each other by just putting them around the center line, right? And that also probably gives us the maximum amount of space, too, I think. Maybe not the maximum amount of space, but it gives us a pretty decent amount of space. Where we can kind of figure things out. Yeah, let's do that. So let's, so do we just want to say, well, part of me thinks that we need to do this in terms of angles. So, hold on. So, Zot, Leo, Ang. And I'm thinking the angle is not a 45. Well, I mean, 45 would be the easiest, but it looks more like a 60. A 60-degree angle looks like it would make more sense with what the zodiac symbols kind of say. And with that in there, we can say IXY, SBC, and then we can do cos, the angle times a distance. The distance is going to be whatever the radius is, right? So let's make a big rad big RB. Let's just make a RB. Okay, and a RS. So RS for one for big, one for small, right? So with RB, now with this, what we can do is we can just make this a little bit easier to work with, right? Because now we can multiply this by the radius, and we were using the big radius first, right? I don't think we were. That doesn't look like the big radius. It's like the small radius. We can find out really quickly if that circle changes size. So comment that out for a second. F4. Yeah, that's not the one. Put the small one in there. Okay, so that we're working with the small one. Okay, so if we're trying to move this, we're going to move it by half, and we're going to move it in terms of cos and sine, right? We're trying to make a times r small divided by 2, and we're gonna go negative. We're gonna go into the negative region. So, but this is trigonometry, so we're not gonna worry about what's negative and what's positive. Just happens, right? Yes, but we want to flip the vector, right? So the vector is 60 degrees upwards, but we want to move it backwards, right? So, let's say vector x equals this, right? And we also need to times it by imp native, so imperial to native conversion. And this one is just the same thing but sine, right? And then here we can say, oh, 0 minus vector x, and then 0 minus vector y, right? So just flipping the vector so we can go in the other direction. And this also needs to be a vy. So let's just make sure that this still works. Actually, impnat hasn't been created yet. here's our imp native, so let's just steal that, put it up here. Okay, so let's just make sure no syntax errors. This still kind of runs, yes. And then this is our circle, right? So we're just trying to back it up, right? So let's put it inside this translation and see if we've backed it up properly. I would say no. I would say no, we have not, and the reason for that is we've done this calculation in terms of native coordinates, which is fine if that's how we want to do it, but we have to. That means that instead of doing this, we got to do translate. Okay, and then we actually just have to give it the vectors, right? And then, you know, 0. And try that. F4. Something, something, we don't know how to do stuff. Something, something. Oh, yes. Okay, try that. Okay, so now, not quite, because the thickness wasn't accounted for, I believe. Right? Because we didn't, well, no, not quite. Okay, let's look at this. Well, this is a radius already. We don't need to divide by 2 because it's a radius. So radius times 1, because why not? F4. Right, okay, there we go. Okay, cool. So now what I'm thinking is, you know, we take the other size circle and we move it in the other direction, right? So we're going to take the same translation and... Actually, no, it's not this. This is going to be the small S. So SX, SX, SY, small translation. So this will be the small translation, and then we'll make another one that will be B for a big translation. And instead of the RS, we'll use the RB, right? And then we still have a problem because this was V, right? So change this to S. Okay, now F4. Okay, cool. And now we're going to take this translation and we're going to paste it, and this is going to be changed to B. And then this size right here, we're going to use the big. And now we have these like 2 tangent circles. Not quite, because we don't want to go backwards on this one. We want to go in the other direction, right? So we'll add there, right? Okay. And F4. So now we have... that's a little bit too big. It's not going to fit no matter what we do. So let's go find the big radius in our configuration and say, no, that's not going to work. How about 1.5, right? And just see what that looks like. F4. So that's a little bit... maybe possibly a little bit too big, but I think with some, if we translate it over a bit, we'll actually be in some good standing, right? So if we just take what we have and we just kind of move it. Now the thing is that as of where we are currently, well, we got to think about the next piece we want to work on is the hook. So we might want to take what we currently have, what we've currently designed, and move this big circle into the center so that we can start designing the other aspect. Now, before we do that, we should just try to translate some things around and see if... so we're going to just say... you know, inch XY SBC, and we're going to move it by like something like 0. Or 1 and 1, maybe, diagonal. And then all this code is just going to be translated, want to go backwards though, 0 minus 1, 0 minus 1. And want to give that a shot and see what that looks like. F4. So, a little bit too much, so 0.5, 0.5, I guess. So So that's a little bit better. But if we made this ring a little bit smaller, that could solve it. Like, this is way too close. This is kind of like 0.4 and 0.4. Let's go look at that for a second. Let's keep it at 0.5, 0.5. And I'm thinking maybe we can squeeze this in if we just shift it over to the left more. Like that. Maybe 0.65. Now it's still kind of close, right? It's still kind of close, or it's like uncomfortably close to the edge. Now this is a 1/2 inch, so this almost is a 1/4 inch, or close. I think we're just going to go with it. And then what I'm thinking is, if this is 60 here, we want to do perpendicular to that, and then make a line this way, and then hook it around. We might actually have to make the tail a little bit smaller, just so it'll fit within the circle we've given it. Let's look at the vector art that we can look at. Yeah, we might just have to do that just to make it easier to... Yeah, okay, that's what we'll do. Okay. So, now that we've kind of put this into place, first we're going to cut this out for a second. And we're going to call this ZODIAC Leo at position tangent, I guess. And then over here, we're going to make that module, and we'll call it ZODIAC Leo position All right. Okay. We'll paste that code in there, and just make sure that still runs. And the reason why I call it position tangent is because if we take it out of the transform that's in here, right, if we just take it out of there for a second and look at it, F4, right? It's positioned at the tangent point between both of the circles, right? So we call it position tangent. Okay. So now that we have this position tangent thingy, it would be nice to add another transform to this that that takes it and puts the big circle as the center, so that we can do some operations, right? So what I'm thinking is this position tangent thing, what we could do is we could say ZODIAC Leo translate So I'm thinking we do this. We do trans to center, takes SBC, and then it takes a 1. And that 1 produces the operation, right? 0.0 minus 1. And then we have another thing. We use the same command over again. SBC 0 plus 1. Oh, sorry, 0 minus 1. The negative is the undo. The positive is the do it, right? And if we do this transformation twice, well, we shift it into place and then we unshift it, right? So I'm thinking something like that. And that translate to center. Right now the tangency is the center point, right? So if we want to module SBC do it, so first of all, this is just going to break things because it doesn't have the children in it, right? So it's just, bam, it's not in there anymore, right? So first thing is children, right? Okay, F4. Okay, now we have the children back. And we know that without the transform, we're right here. So we want to go in that angled direction by the radius, right, to get it kind of centered. So first we're going to comment this out. We're going to comment this out so we can get a sanity check on where everything is. Right? So yeah, from here we just want to go by the radius. And we already have the vector we want, right? It's this big X, big Y vector here. And impnat, we're going to need those, right? So we're going to steal those, right? We're going to steal those. Okay. And then we also need to steal this conversion thing, right? So this is why writing code in this way makes it a lot less efficient, because we have to keep on reevaluating things and re-looking up values rather than just having them as globals. But that's what we get for adding more abstraction, right? More abstraction, more cost. So with this BX, BY thing, the angle is like 60 degrees upwards, so we want to go negative. So we're just going to say, for this translation, BX, BY, we use a normal translate, right? Yeah, so we are going to take this translate, and we also want to scale it by 1 minus do it, right? So it'll be, if do it is positive, then it goes backwards, right? And that's just so that we can, the do it just makes it an undoable operation, right? So you give it a positive to do the operation, you give it a negative to undo the operation, right? So this BX, BY thing, that's fine where it is. And then just do this. And then just give that a run, see if we have that correct. First of all, RB doesn't exist. So this RB is this big rad, right? So let's go steal that from previous. Okay, so a lot of stuff is just going to have to be stolen more. Okay, so now if we look at that, oh, that's not what we wanted, is it? So I guess we don't have to do 1 minus do it, do we? It's just good as it is. So, or actually, first of all, let's remove one of these transforms. Let's just keep one of them. Okay, F4. So what I'm seeing is no transformation. Oh, you know why? Because 1 minus do it equals 0. It's do it minus 1. My bad. So if we want to invert it, do it minus 1, not 1 minus do it. So now if we do this, are we getting nothing? Do it minus 1 or 1 minus do it. 1 minus 1 is 0. Okay. Yeah. We don't know what we're doing, huh? Oh, because it's in the range of, Okay, hold on. So if we really want this to do what we want it to do, the sign equals, do it equals -1 or 1, right? So do it plus 1 gets us 0 or 1, right? 0 or 1. And then we have a 1 minus a 0 or a 1. So 0 or a 1. 1 minus a 0 or a 1. So if this is... Oh, sorry. Do it 0 or 1. Yeah, because it's -1 or 1. So we get a 0 or a 1. And then 1 minus a 0 or a 1 gets us a 0 or a 1, right? A 0 or a 1, right? So then we do this, and then we have a 2. No, actually, no. This is in the 0. This is -1 or 1. If we plus it, that gives us 0 or 2. 0 or 2, right? So let's do 2, right? Because it's 0 or 2. So it's either 2 minus 2 or 2 minus 0. Okay? And then because it's 0 or 2, we have to then divide it by 2. God, that is so much work. Sign. Invert sign. Like, why? Why is it so hard? I don't know. It is. Okay. So, F4. Let's take a look at that. No dice. Let's make this times 1 for a second to make sure that there's no other mistakes here. Yeah, so if we do that, right, this is like way over there. And if this is like -1, F4, way over there, right? So our math here is not correct, right? If we do a 1 and -1, so once again, do we have this correct? We're saying it's a -1 and a 1. So like, here's the steps. Input. Do it is a -1 or +1, right? Offset +1. So if we offset with a +1 to each one of these, right, +1, this becomes, if we add 1 to -1, it becomes 0, right? Or this becomes +2, right? Okay, cool. So are we doing that? Well, here's the input. Here's the +1, right? So we either have a 0 or a +2. Okay, so good so far. Okay, so 2 minus. Well, 2 minus 0 is 0. 2 minus 2 is 0 as well. Okay, so we want to flip that. We want to flip that, right? How do we flip that? We subtract what? -2. 0 minus 2 is negative. 2 minus 0 is a 2. 2 minus 0 is a 2. 2 minus 2 is a 0. Okay, so that makes sense so far, right? So the next thing is 2 minus, right? So it's a 2 minus, so it's 2 minus. So 2 minus. So if we have 2 minus 0, 2 minus 0 is 2, right? 2 minus 2 is 0, right? So you see we have this, okay, so far so good. And then if we divide by 2, we get 1. Oh, we don't want to divide by 2. We just want to shift it back, right? So if we subtract 1 from this, right, this becomes 1, this becomes negative 1. So we don't want to divide by 2. We want to minus. We just want to minus 1. 2 minus, and then minus 1. Minus 1. So minus 1. And that gives us, if we minus 1 from here, that becomes a 1. And that becomes a negative 1. Right? So we flipped that. We flipped it. We've done it. We've done it. We flipped it. Excellent. So we flipped the signs. So let's put this S back here. Why is that so hard? I don't know. F4. So now if we look at that, hey, look at that. That's exactly where we want it. And we use the S variable. So now if we go over to this trans to center thing, and we use a minus, right, it's going to go in the other direction, right? It's not going to work, right? But the cool thing is that if we this is called position tangent, right? So F4. So we can translate it to center. We can do some work. And then when we're done with that work, we can undo it, right? So we can do the work, and then we can undo it, right? So F4, right? Okay, cool. So we can do it, and then we can undo it, right? Which means that that we can now think of this circle as being in the center, right? And with that circle being in the center, it gives us the ability to kind of like chop it off. We can make a square. We can take a square and chop off this side. We can chop off this kind of quadrant here, right? We take the square, we make it the same. We make the radius of the square the radius. We make the diameter of the square the diameter of the circle, and then we cut off this quadrant, this lower quadrant right here. So we can see if we are on this kind of axis here, we can chop off this quadrant, and then we can put something better in. So let's say that that we want a difference between this stuff, right? So we want a difference between this and whatever else we're putting in here, right? So what we're putting in here is like a V-carve inch pocket, and the pocket is going to be what? Well, we have the big radius, right? So the big radius, this big rad, RB, right here. Well, first of all, let's take these kind of variables, and let's put them at the top level, right? Okay, and then the big radius, which is in inches. Big radius, and we'll make that 0. Let's put that in there for a second and see what happens. F4, it's in the center. And I was expecting... Oh, you know, this is a radius, but it's a square, so the radius needs to be times by 2. Okay, F4. So now we have kind of this square that's kind of breaking in there. So the first thing I want to do is I want to rotate it by the angle that I was using. So this Leo angle we want to rotate by that. So we want to go rotate angle equals this, and the vector equals 0, 0, 1, because it's the z-axis. Okay, and now we're going to see that square rotate, F4, right? So now, we want to just move it, we want to take another vector that we want to take a perpendicular vector, so we want to subtract 90 degrees, and we want to move this way, right? And then we want to subtract another 90 degrees. Well, actually, we go 90 degrees this way, and then we go negative this way on the 30-degree vector, right? And to get the instead of the square being centered right here, we want it kind of like to start. We want the top left corner to start right here. Everything's kind of, our basis is all skewed, but just trust me that I know what I'm doing. So, we want to just say, the vector x equals yeah, let's say vector x. So we have a vector x or a vector y. Actually, it's more of a vector y. Vector, or actually, let's call it vector a. Let's call it ax, because ax is going to be the up vector that's going like in this direction, and then and then bx will be this one. So vector ax equals the cos of, A1, angle 1, or we could call this x1. x1 uses A1, and A1 equals this Leo angle, right? And plus 0, right? A2 will be the perpendicular, and that's going to be like minus 90 degrees, right? Because the degrees go counterclockwise, we want to minus because we want to go this way. Okay. So cos A1 times the direction, the amount. And that's going to be the radius of the big. Copy. So we're going to take the big radius, right? And then after we've done those calculations, we need to scale it. So times imp nat. Okay, then we have the y1. Okay, so this y1 vector is the same thing, except it's sign, right? And then the x, the 2 vector, this vector x2, just takes angle number 2. Okay, and let's just F4 for a second, make sure that everything is still here. Okay, cool. So now what we're going to do is we're going to say, and we can just add the vectors together, right? So we don't have to do it. We don't have to do it twice. We don't have to do 2 translations. We can just add the vectors together. So translate, and then we go x1 plus x2, comma y1 plus y2, comma 0, right? And then if we've done all that right, it'll get chopped off where I think it's going to get chopped off. Otherwise, we've made a horrible mistake. Close. We're close. It got chopped off over here. And let's think about why that is. I got the x vector wrong, but the y vector actually needs to go backwards. So this y vector, we need to take this and invert it. So actually, sorry. This vector here is the major axis vector. Right, this one's the major axis vector, and this one is the minor axis vector. And this minor axis vector actually needs to, we need to do 0 minus. We need to go in the other direction, and this one can be, we'll do 0 plus here. Okay, so now let's look at that, F4. There we go. That's, just despite it kind of cutting into here, that is actually what we want. But we just need to, we need to... So right now it's right here. We need it, we need to make it the radius thick so it stops chopping. The radius, yeah, just the radius, right? The radius without the thickness will just chop off right here, and that'll be good, right? I think. Or on the, so where's this box? Right here? So on the y-axis is where we're having problems. So this one right here, F4. So that's a little bit better. But you'll notice that we should really chop it off at... So let's open this up a little bit so that we have a little bit more room to think here. And, right, let's just throw this in here like this. Okay, let's make sure that still compiles, and then, well, let's... Okay, so let's run that. F4. Okay, so this needs to be... We need to add that thickness, I think. Or hold up here. I think we're not using the... I don't think we're using the axis that we think we're using. Hold on. Okay, F4. So if we make both of these 2, right? Too much is getting subtracted, right? And if we make this like a 1.8, is this going to move? Okay, so that's not the axis we want. We want the other axis. So we can keep this as 2. Make that a 1. F4. Okay, so that's more kind of what I wanted. Now... Oh, the problem is that if we do this for the x, right, this is the x-axis here, then when we try to move this, we need to know those thicknesses, right? So so this is the width. Well, we thought it was the width. It seems to be the height for whatever reason. Probably because we rotated it so much, didn't we? Where did we rotate it? So this Leo angle is what, 90 degrees? Yeah, so that's why width and, Okay. So to understand what the hell we're looking at, rec, width of the rec, RB times 1. RB, actually, this is the height right now. And the width RB times 2. Okay, so it's still gonna be wrong, but we're getting closer. So right here, this is gonna be the height. So usually it's width height. So that is swapped because of the 90-degree rotation, right? And then in these calculations where we're trying to apply these angles to things, we can think of width as this and the height as this, right? So when we're looking at this vector here, and we're looking at the amount of translation we want along the major axis, we want to look at the height for the major axis, right? And then for the minor axis, we want to move by the width. Okay, so let's plug that in and see what happens there. So now we got this like way over here. Not exactly where I expected it to be. Right, we're trying to... So we're just sucking is what we are, what we're doing here. Well, this vector here, angle 2, is a minus 90 already, right? Mm-hmm. That's why it's like that. Oh my god, sick of this. You know, it'd be easier if we just, it'd be easier if we just, chopped it in half. Okay, so hold on. So all this stuff is annoying the hell out of me right now. So this translation right now, let's get rid of this translation and put it back when we're finished trying to figure stuff out. Okay. And now that we're trying to figure stuff out, let's just put we just want to put a square here. Actually, yeah, if we put a square here and delete, we just want to delete the ring. Okay, first of all, let's take back a whole bunch of this code we already wrote. Like this stuff, let's just try again here. Let's just try again. Say give up there. We only want to delete. We want to keep the full circle here, right? So we only want to delete this big ring, right? So trans to center, and this is the big ring right here. This big ring. And if that's the case, we don't even need this, right? Because we just want to... Because this is already in... This big ring is already here, right? So this Leo trans to center here, and this difference thing, let's get rid of that. Ooh, that's scary. We got some serious... Okay, so delete these two brackets, and then delete these two brackets, and then we still have this thing here, so we had the undo operation. Let's delete all that. Let's delete all that. We're getting too complicated. F4. Okay. So... Oh, I see. So that was so I could visualize it. Well, I don't know if we want that. So we know that this is kind of like with this circle in the center, right? So if we just do a difference between this and do difference, and we have the original thing, and then we have the square, right? So we want a vcarve inch pocket SBC. We want to use the span, and the span will be the span of that rectangle is going to equal RB times 2. Okay, so try that for a second, and things have blown up in our face. Oh, okay. F4. Okay, so that's kind of where I expected it. So can we just get away with moving it down, right? So can we just translate it, right? So can we just go inch xy san 0 minus san divided by 2. And then 0 plus san divided by 2. Right, if we just translate it like that, can we get it cutting off things kind of like where we want it to be cut off? San is unknown because... Oh, this needs to be SBC. Okay, F4. So, wrong direction again. X needs to be positive. 0 plus. The Y needs to be negative. Okay, so let's try that again. F4. Let's go over here. Not quite what we want. We need to move it over a little bit on the on that x-axis. We need to move it over a bit. So I don't know how much we want to move it over a bit, but we can just well, we could just try to rotate it. We could try to rotate it, right? So if we rotate angle equals, right? And if we try to rotate it by, I don't know, if we want the deletion area to be kind of like perpendicular with kind of this thing here, then we would rotate it by this Leo ang, right? Rotate angle, Leo ang, and then vector equals 0, 0, 0, 1. Try that, see what that looks like. F4. Okay, now the next thing is, with it like that, we can't really just XY move it. We gotta... Let's just focus on deleting this section first, right? And to delete this section first, right, we have to rotate it by this many degrees, right? And then we just have to do a vector instead of moving it like this, we have to move it by some trigonometric value, right? So it's going to be like move it by cos of this angle, right? Cos of this angle. Cos of that angle, nothing, right? Oh no, times the span. And this is the sine of but that angle is 60 degrees. And we want the deletion to go in this direction, right? So I'm going to take that span. I'm going to go half that span, right? Because we want to just get off the midpoint. And this Leo angle is going to be minus, it's a 60-degree angle. We just minus 90. Okay, let's give that a shot. F4. Bam! Much closer. I see that, well, first of all, we need to get rid of the wheel for a second, because the wheel is making it hard to know what we're working with. Okay, F4. So, it looks to me that this midline kind of thing has been moved. And it's like right in, oh, it's right in the middle of this circle here, right? So that's why it's kind of like chopping off maybe more than we would like. So you know what we're going to do? We're going to make it bigger. We're going to make it even bigger. We're going to times it by 3. Okay, F4. Okay. And then what we're going to do is we're going to try to get some of this back. We're going to try to get some of that back. We're going to try to get this much back, right? This, right, we're going to make us another square. We're going to rotate it by 30, by that, not 30 degrees, by that 60 degrees, the Leo angle. And we're going to delete some of the deleter. So this is the difference and union. So in here, we're going to create a this is the deleter. So this is the deleter, and we're going to delete some of the deleter, right? So it's like kind of weird to think of it like that, but that's what we're going to do, right? So this is the deleter object, or the deleter code. Make sure it still works, F4. Remember that this circle here is actually at the origin right now, in the frame of reference we're in. We just don't see it that way. Okay, so this union right here, we're going to do a difference. Okay. And this is deleter. Right in this section is the deleter, which is like crazy, but that's what's going in here, right? Okay. F4. Okay, so to get this, we're going to start with the square. And we're going to move it, its corner right here. Right, so it's going to be here and here. Actually, hold on. Yes. Yes, that's, okay. So, first we're going to try Like, how big does it need to be? Well, we could just keep the same SAN. SBC, span, right? I think that's big enough, right? And then once we have that, right, we're going to do the rotate, so we can do all this kind of stuff, right? It's all this stuff here, right? It's pretty much all the same kind of code. But then when we do the integer XY translation, that's the part where it gets different, right? And we're actually going to move by the Leo angle yeah, actually we could just move the whole square up, right? So instead of Leo angle minus 90, we're just going to do this. Okay, try that out. F4. There we go. That's good. So now we can kind of like, from here, we can... That doesn't look quite right, does it? Oh, that'll work. I'm not quite happy with that, but yeah, that is 2 tangent circles. I'm not happy with, like, right here, like, kind of to me. But yeah, so now that we have this, right, we can add, like, a little hook kind of thing, a little U shape, and then hopefully be done with it, right? So let's, I don't know, give that a shot. How are we going to get over here, though? Well, we have some line code that we haven't done in a while. But let's first of all, right, within here, within this translation is kind of where we want to be. And we got this union of this stuff, we got this difference. So this is a union. Add tail. So right here we're going to add the tail. Okay. And the first thing we're going to do is just a, we're just going to do a vcarve inch hole SBC and just like, I don't know, 0.25 or something. And I think that's all we need for that. And that should be right in the center point here. If we know where we are, and if we don't know where we are, then 0.5. If we don't know where we are, then that'll happen. So difference, union, oh, this is in another difference. We need to back out of here a bit. The add tail needs to not be in here. Right, we're inside the deleter. It even says, though. It even says that we're inside the deleter. So we need to add the tail here. This is where the tail gets added. Okay. So now let's see if we have a little circle going right in there in the middle, right? Still no dice? We still don't know what we're doing. Okay. We still don't know what we're doing because we're still inside of a difference. So I don't even know what that difference does, but we're inside of a difference. Okay, just F4. Are we there yet? Okay, now we're finally there. Okay, well that's nice because we got more room to work with, right? So, big circle and who knows what. So I don't know exactly what all this stuff is, but I know it's a big circle and who knows what's over here. And then outside this difference, that is the end of this big circle and who knows what's. And I don't know what exactly is going on here, but I'm trying. Okay, so F4. That circle is in the right place now. We can do 0.25 or whatever. And so we want to get, we want to make like a angled line. So we want to put this over here. And then we want to travel down some amount in that direction. And then we want to put another one of these circles on it and give it a little hook and just call it a day. A circle with maybe even less of a radius, because I just don't think that a circle of the same radius is actually going to fit, unfortunately. So, so medium, big, and then small, right? The tail will be the smallest part. So in order to get that working, let's first of all try to remember what our line code is, because I think we have a vcarve inch line. I think that's what it's called. So let's go look at this. So we have a thing called vil, I believe, right, for vcarve inch line. Yeah, and it takes a thickness, and then it takes a x and y location. So the thickness is, you know, somewhere in all this code. So for making a zodiac sign, that's the thickness we want. And so right here, it takes SBC, then it takes the thickness, and then it takes some vectors for where it needs to be. And hold up here. Oh, no, that's fine. Okay. It's not an auto-generated polygon. That's why that works. So, to get over here, so 0.1x, 0.1y, and then 0.2x, 0.2y. And these are in terms of inches. And we'll do 0.1x equals what? Well, we're going to do the cos of some type of angle. And that angle is going to be a perpendicular angle. So this Leo ang minus 90, right? So ang let's call it A1 for angle 1. Angle 1 equals this thing minus 90, right? Or angle, AP for perpendicular, angle perpendicular, and angle major. And this is not the angle at all. What the hell? This is the angle. Okay, so we got these angles, right? And then for this point here, we want to get this point over here, right? So we're going from here, and we're going to go the perpendicular amount, right? So we're going to go angle perpendicular, and then we need to multiply by however big this circle is. How big is that big circle, right? And for the big circle, we should have like a radius big. And radius big is this big rad, right? So RB is like way out here, so we can just use that. So RB times radius big, and then P1y equals the sine of that perpendicular angle times the radius big. Okay, and then for the second point, right? Let's take this for the second point. This is 2x and 2y, and then we want to do the we want to do this direction, right? Hold on here. Perpendicular. In the major, we want to minus the major, right? So we want to go negative. But we want the starting point to be here, right? So it's going to be this minus that, because we're gonna go backwards. And we already have a problem here with bracket balancing. I see. So I want to just put all that formula nice in here. Okay. So let's give that a shot, see if that blows up on us or not. Okay, cool. So that's where I want it to be. Now what did we say for the length? Like, is there a length? So we're just, like, arbitrarily going by the big radius? For whatever reason, we're just going from that point. We're just going from this point by its radius, which means that this intersects, like, right here. Okay, sure, why not? And then we want to make, like, a little hook, right? Part of me just wants to give up and just give it, like, an angular kind of hook, right? Like, just give it a, well, let's put a whole bunch of breakpoints here for a second. Part of me just wants to say, you know what, just this wheel frame thing or whatever. Well, first of all, let's make sure we have enough space for everything. All right, so let's put back this transformation and just go F4 for a second. And yeah, part of me just wants to go boom, boom, right? Give it a little square shape, especially because of the room that we're running out of. Because we are running out of room. That'd be the easiest, right? Because right now, to get a whole curve in there, now I would like the line here to match up. So if we take this and we go negative major axis this way, and then we go perpendicular axis this way. Do we end up here? Is that where we end up? I would kind of like to know that. Well, if we go here by the perpendicular axis, and then we go here, I'd actually say that oddly enough, we're actually probably already lined up. We're probably already lined up. It's just that our angle is this, so we're lined up like this, right? But I'm looking at this curve here and kind of thinking that it continues out here, but it doesn't. So to give that a little hook, what do we want to do? Well, most symbols have a hook on them, right? Like, there's not really many that don't have a hook of any sort, so we might want to not try avoiding that kind of hook that needs to be there. So I'm thinking we just draw a line here to here to here, right? And then we just chop it off here to make it, I don't know, for whatever reason, for style points or whatever. But the easiest thing to do would be to make another line, right? From point 2 to another point 3, right? So if we want to make a point 3, right, just keep on drawing points. We would go P3, X. We're going to start at point 2. And we're going to add, and we're going to go in terms of the perpendicular vector, right? So we're going to use the angle perpendicular. So angle perpendicular. And the amount we're going to move is kind of an arbitrary amount. So I'm thinking 1 for now, until we figure out something better. And then over here, we're just going to make another one of those line segments, right? So we're going to take this, we're going to make this, a 2, this is a 2, this is a 2, this is a 3, this is a 3, right? And then F4. Okay, so we're way out there like that. And I'm thinking to myself, you know, we just do that, right? And call it a day, right? Well, not that, but one more thing, right? So we're thinking, okay, after we have that, then we want to go back up a bit, right? So we're saying that we have another P4, and P4 is, we take point 3, we start at point 3, and we want to use the major axis this time, right? So major axis, and we want to go 3 to 4, right? So we're going to copy this, and this is going to be from point 3 to point 4. Okay, F4. Okay, so something like that, right? So it's kind of like it's slightly stylized. It's not the same, right? It's not like the other ones. And it's like maybe, I don't know. I don't know how important it is that it be you know, I don't know. Maybe that's a bad idea. But now that's there, right? We have at our disposal the ability to figure out where. So we just need to circle through these 2 points, right? So if this length here from here to here is 1, we just need a circle whose radius is 1. That's in between. This is point 4. 3 and 2. So between points 2 and 3, we need to make a circle. So here, we could do this. We could go, you know, we could, we can translate inch xy. I don't know if we have such a translation, though. I think we do. And we need 0 plus 2 and 3. So 0.2x plus 0.3x divided by 2. Right, so that's the translation we need. And then 0 plus, guess what? 0.2y plus 0.3y, right? We're interpolating. Put this comma over here. I don't know if inch ixy is a thing we have yet. Now, if it's not, we can just not do this. We can use the individual commands. I guess it does exist. And then here, we can make a circle, right? So we can say vcarve inch wheel, and we need to use SBC argument. We need a radius. The radius is going to be from here to here is 1, so that means the radius needs to be 0.5, and then we need to use the thickness of the zodiac sign. Okay, F4. Okay, so that's where we want it. And then we're saying, okay, we want to remove this middle line, right? We just want to remove it because we're going to draw the arc instead, right? F4. And if we do that, then we have to we need to chop this circle in half, right? We need to chop this circle in half because this part is not welcome, right? Because we get this kind of weird kind of thingy thing, right? So to fix that, we're just gonna to fix this, we're just yeah. I don't like how the spacing between here is slightly off. But maybe I shouldn't worry about it. Let's just fix this. So, this is the wheel kind of thing. And to fix that, all we got to do is do a difference and just chop it in half, right? So chop it in half by just creating a pocket shape. And the pocket shape needs to be, I don't know, we could just make it 2, 2, right? It doesn't, we don't really need to 2, 2 with the 0 thickness. And then we need to do some more, because right, this will just delete the whole thing, right? And we need to translate it upwards, right? So to translate it, we just need to say inch xy SBC, and we need to go by these coast whatevers. We need to go take kind of this kind of stuff. So translate it by cos. The major axis. We're going to go by the major axis times. So since we made it 2 by 2, that's the whole entire width. We want to go by half. So we want to go times 1. And sin am times 1. Right? Will I ever remember what this code means if I come back to it in a year? The answer is absolutely not. That's not what I expected at all. Oh, you know what? So this rectangle here, for this to work correctly, this crazy rectangle needs to be rotated by that same angle, right? F4. Now I'm still in trouble. Come on. Oh, hold on. Oh, first of all, this is the wheel. We don't want to rotate the wheel. We want to take the wheel, right? It's a difference. We want to take that wheel. We want to rotate this. We want this to be aligned. When we translate it, we want its translation to be aligned with its. The translation needs to be aligned with the box's major and minor axes, right? So, okay, cool. So something like that, I think, is good. Now, the other thing is that if we look at some of the other zodiac symbols we have, let's go look at what we have so far. This has some straight lines. 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 So to make a zodiac symbol here that has absolutely no straight lines incorporated into it makes me say, maybe not. Maybe, maybe the straight line was a good thing. Maybe it was a bad thing. Can we find any examples where there's some straight lines? Leo zodiac symbols. I don't think we're gonna find anything where it's like not curved. I mean, we could look for specifically angular and see if there's any angular illustrations that have, you know, the kind of stylization that I'm expecting. But I don't know. Right? I don't see any such stylizations. I mean, I could be the first one to do it. But yeah, I'm thinking we could just chop it off right here. Chop off this little rounded tip. And then that would be good. I think that would be good enough. Or... I do like how this kind of just fits together nicely, though. So... yeah, I'd say we just want to chop this off right here. If we chop that off, we'll be in a good place, I think. So... let's go look at the other option that we had, right? So we thought we could do this. But the alternate option, right, this IXY thing, so if we comment this out, F4, right? So instead of that, if we put this back in, we have kind of this. Part of me kind of likes that just because all of my other symbols have some type of angle incorporated into them. So if we, once again, if we look at kind of the other stylizations, there are some angular elements, right? This doesn't have much angular elements. This just has a little thing right here. So I guess that doesn't. Okay, I guess we don't have to get that crazy, right? Like, if that's not... right? Maybe if you look at that, they're like, I don't recognize that. That's not the way it's supposed to be anywhere else, right? So maybe we don't do that. Maybe we don't do that. Maybe we back off on that craziness and we put this back in. And then we comment out, it was this one, right? Okay, so if we do that, F4. We got this arc thing. And then let's just chop off the tip right here, right? So, to chop off the tip, first of all, we got to find that line. So this line right here. We just want to chop off the first point, right? So we just want to do difference, and we just want to chop it down, right? So, okay. So we want to chop off the tip of this line. In order to do that, all we should need to do is be able to do a translation. So inch xy SBC, and it's the final point, right? Yeah. So P4x, P4y. And let's just put a square there. So this pocket kind of square, let's put one of these things here. Right, it's already rotated, like this whole thing right here. This whole thing, we can just take that and that should be good, right? Except for this amount needs to be, this offset amount shouldn't be 1 though. It should be, no, because it's half of that. Yeah, so that could work. If we just take this whole thing right here, and we just put that right here, boom, kind of cut and paste, but if we take that, that should chop the tip off. Yeah, there we go. Yeah, I like that better. I like that better. Something about just not having those rounded termination points look kind of sloppy. Okay, so that's pretty good. Now the thing is that this is kind of big. It's kind of big compared to the other ones. So how are we going to fix that? Do we want to make this circle slightly smaller? What do we want to do? And if we make it slightly smaller, does everything just fit together parametrically awesomely, or did we do some guessing and checking, and so it doesn't? It's not completely parametric. So we could try. We could try if we make if we make this big radius. If we make it like I see a problem here. The small radius, we're taking the thickness and multiplying by 1.5. 0.5 times 1.5. That is a weird way to write code. Okay, so we're going to take this and just try to make it smaller and just see what happens. Hey, look at that. Not too bad. Also, this circle in the middle we have to get rid of. But if we make this like a 1.4, just make it a little bit smaller than it was, even though I do like the 1.5 or whatever. Yeah, if we make that a little bit smaller, I think we're in better standing there, right? So it dynamically adjusted. Yeah, if we do that and we just shift it around a little bit, I think we'll be good, right? Just tweak that a little bit. So down here where we're kind of doing all this stuff, at some point in this train of thought, we decided just to make a little thing to know what the heck we were doing, and that's where that came from, right? Okay, yeah, so if we comment that out, we get rid of that little dot in the middle. And now we just got to tweak the positioning a bit. So if we tweak the positioning, it needs to go up a little bit. So, first of all, minus, I don't know, something like that, F4. That's more down than I wanted, 4, wrong amount, okay. So, slight tweak. Maybe, like, 42.42. Okay, cool. So that's pretty centered. That's good. I like that. That works. Okay. Everything kind of just fits together nicely. No weird artifacting. All right, the math is correct for this. Okay. Now that we have that done, we can, first of all, F4, make absolutely sure that's still correct. We can take this code we used while debugging, and we can get rid of it, right? We can close this, and we can go into our cutting sheets, and we want to make a new cutting sheet, right? So first of all, let's go open up one of the old ones, right? Like this one, right? And let's make the cutting file sheet. something, whatever. So new, and this is going to be Leo, right? So Leo 001, and save that into the cutting folder as Leo 001. So Leo 001.scad, and then copy paste, file new, Leo 002, save, and Leo 002.scad. Okay, so now that we have that, we can open it up and see that it looks correct. So ignoring unknown module ZODIAC Leo. So let's go open up the main cutting sheet file, because maybe we forgot that, right? So file, and so this cutting sheet, right? ZODIAC Leo does not exist, huh? Oh, you know why? Because this is, the zodiac sign names are actually camel case. So this is Leo like that. And then this one, like all these things, so a lot of these things should be camel case. So this Leo and this Leo should be camel case. This is all caps though. This should be camel case. And then this one should be camel case. Okay, let's give that a shot. So F4. Okay. And zoom extents. So there we go. So file, export, export as SVG, Leo001.svg, save. Okay, close this, file, open, and we're going to open the other one. We're going to open the Leo 2. So here's Leo 2. Did I open that? Oh, I opened that in... I don't want to open it. I want to actually open it in OpenSCAD. I don't want to open it in the text editor. We already did the text editing part. So we're going to do this. Zoom extents all, render it. And then this is just the locator holes. Export as SVG. It's nothing fancy. It's the same for all the models, but we're just doing this for completeness. We're doing this, even though it's the same for all the models. Okay, so now the last thing we want to do is we want to open this up and just take a screenshot for posterity's sake. So right here, snip, right? So we can add it to, if we come back to this code in a year, I don't want to have to rerun the code. I just want to like be able to do a little slideshow gallery to know if it's what I want, and then if I'm more interested, I can actually open up the source code and edit it. So, or include the source code in a project or whatever if I like what I see. So save this as, and this is the Leo, so leo.png. Okay, so close that, and then let's kind of review what we have. Let's review the little screenshots we have here. So a little summary. So we got that, we got that, we got that, we got that, we got that. Okay, so Aries, Cancer, Gemini, I don't remember. Oh, it's the thing I just worked on, Leo. And this is a bull, so this is Taurus. So that's good for now. So let's close this, and once again let's do a git bash here. Or actually, well, yes, we'll do a git bash here, and then we'll back up. So cd ... cd ... cd, no. Okay, git status. Is it gonna, okay, git add dot, and then we'll do a git status again, make sure that nothing looks unusual, and then we'll commit it, we'll push it, and then we'll be probably done for today, because I think that I'm just tired of this for now, but that took longer than the other ones. The other ones we did took like 45 minutes. This took like an hour and 30 minutes. Now, there was actually a lot of confusion, though, with getting that. It was a lot more complicated. It was a lot more complicated than Cancer, Gemini, Taurus. Yeah, it is the most complicated one in terms of the structure. So that actually makes sense that it would take the longest. Okay, so git status. Okay, git commit -am. Leo symbol done. So the Leo symbol is done. That's what we just did. And then we're going to move on to the Virgo symbol, which is actually kind of more... there's more lines in the Virgo symbol, but depending on how we can... depending on the underlying structure of this, it might just be a lot of repetitiveness, so it may or may not be more complicated than the Leo symbol in terms of the geometric complexities here. So, git status. Okay, git push, GitHub, master. Okay. And so we've actually done 1, 2, 3, 4, 5 out of 12. So the idea is that we want to get, since we're on a budget here, we want to get a lot of content ready for the laser cut, not for the laser cutter now, for the shop bot. If we want to try to make one of these tabletops, right, we already have all the parts for the bottom, but if we want to make one of these tabletops, we're going to have something, have it so that like every day we can actually cut something of value. So we should also probably start reserving time in anticipation, but do it like a few weeks out so that we get the time slots that we actually want. Because this is kind of coming down to the wire here. So we also need to take totals of the parts we already have. I don't know, I'm tired. Okay, so that was that. That's the Leo section. I'm going to stop this stream. I'll do more later. Or maybe not. I don't know, I'm tired.